what you did.
What did we do? So it's definitely not right. So we tried to,
Good job.
wow, I don't even know what.
Thanks.
We tried to break up the bottom equation so you could not cancel out, but then you do 1 minus x, 1 minus x, and then just 1 over x.
Let me write it down.
But
So you did this. Is that correct?
no, sorry, that's not what we did. Maybe that's right. We just
But
did
that's
1 over
probably
x.
right.
It is. Go, please.
That's what we did.
Okay, everybody look at the board. Everybody look.
Look
Look.
after that.
Yeah.
Yeah.
Anytime, look at me. It's what the AP test writers do. They know the kind of problems you've done for years, and they find a way to create a new problem that you actually know how to solve. But your brain tricks you because you're like, I've never seen that before. So you have to stop trying to solve a problem by remembering problems. You solve a problem by remembering concepts. So the concept here is anytime you have something subtract something, you can always factor it. All you have to do is take the square root of the first term. What's the square root of 1? 1, write it down. What's the square root of x squared? X. Write that down. Subtract, and then just do the opposite. Works every time.
Oh, we talked about that today.
No worries. You good? So now what?
Well, we didn't get to that, so now.
Oh, there you go.
So now.
Yeah, 1 over 1.
So you would do one, I would just do 1/2.
Yes.
Awesome.
Because what's this equal to?
Can we do the HA on this one?
Yeah, then you gotta go with the exceptions again. Any exception? If x equals
0.
1, that's a problem. If x equals 1, this is a problem. Why is that a problem? That would be undefined. So we've got our list again. I'm trying to convince all of you that it's really, oh, please.
Sorry. So since we're approaching 1, though, we're not going to 1. We don't need to worry about if it's at 1.
There you go. And in fact, even better, just come over here and say, well, we know what's happening when x equals 1. What's the y value?
Wait, no, I didn't know.
So if there's infinity on the top.
It's probably good.
Okay, I don't know.
You're okay.
It's 1/2.
So here's our formula, right?
And then
You're good. You're good. We're here, right?
Yeah.
Okay. You plug in 1. What's 1 minus 1?
0.
And the bottom would be?
0.
What's 0 divided by 0?
Undefined.
There we go.
We give it. Right.
Wait, if it's not like actually equaling 1, wouldn't it like not be undefined because it's not dividing to be 0?
You're on the right track. I just want to clarify one small thing. We got to go back to this fundamental idea that when you start the problem, you really should look at the green box and this red box separately. They don't go together. The green is just a formula for a bunch of x, y pairs. The red is saying, let's go find out something about those x, y pairs. Does that make sense? Good. So this second line, we found something out. We found that if you plug in 1, the y value is undefined. Now that's not what they're asking for, but we did find that. So what I was saying to Allie is, well, don't lose track of it. Maybe it'll help for some other part in some future problem. So we know that now, right? But to find the limit, we want to do what you said, Ryan. We want to have x be close to 1, which means this can be 1. So we can come here and say this is the limit as x approaches 1 of 1 all over 1 plus x. And now the red, Allie, help me again. Allie, what's the difference between the red formula and the orange formula? Sorry, the red and the green. That's terrible. That's bad. Sorry, the green and the orange.
Okay, I was like.
Yeah, you
sure
lost
what
2.
I'm comparing.
You lost 2.
So the green one is looking at all possible x and y pairs, and the orange one is looking at all the y pairs with x leading up to 1.
Perfect. And then, like I said to Ryan a minute ago, keep these separate in your mind. This is a formula for finding a bunch of XY pairs. This is asking you to do something with that formula.
Yeah.
It just says go pay attention to this, right?
Yeah.
And you did, and you correctly found this to be a Y value that's really close to 1/2. Does that feel good? Heather?
Why is it why is it 1 over 1 plus x? Where did you get the 1 to add to the x? On the top, when you break it out, I probably would have just been like 1 over x.
What we did is we had to change, so you're asking about how did this become this? Oops, let's do it the other way. I think this is what you're asking. Is that correct, Isaac? You're wondering why this becomes this?
Yeah.
Right? Good. Okay, the quick thing to remember is that anytime you have one term minus another, they can always be factored by simply taking the square root of this term. So you tell me, Isaac, what's the square root of 1?
1.
There it is. Then minus the square root of this times the opposite. Is that okay? It is, it's exactly difference of squares. All they did to mess you up is they flipped it right. Yeah, good work. Please. Hold 1 second. I want to finish your, you're just fine, so I want to finish your. Oh, you're good. So Al, you good there?
Yeah.
I'm going to finish, if anyone's interested, because I want to have a recording that has the whole problem. So we're good on the limit as x approaches 1. We've done that. A lot of people working on things, just keep working. Anybody still listening here? Just show me that you're listening. Awesome. So for those who are still listening, I'll pay a full ticket if you tell me what's the quick way to find the horizontal asymptote. Howard.
Oh, or you can do it. He raised his hand.
Oh, you got it.
Okay, well now you said you can use the orange one, not to compare problems, but it would work.
Yeah, it would. Let me clarify something. I really like what you said, because you remembered me telling you not to compare problems.
Yeah. But it makes sense why it would work.
That's the difference. Yeah, there's nothing wrong with saying, hey, use this before. It's just like, as long as you know the why.
Totally.
Yeah. So what happens as x approaches, so like, as Ali's saying, we already just talked about how this formula can find any xy pair of this, as long as we're not trying to find what happens when x equals 1, which we already know. So we can just say, well, this is related to what you've been asking too.
Yeah.
It's a chart again. If x is growing, so we're going to give some tickets there in a second. Clayton, if x is 100, what's y?
Really close to 0.
Right, because it's 1 over 101. If x is 1,000, what's this one, Clayton?
Even closer to 0.
Even closer. So we found a horizontal asymptote. As x approaches infinity, y is approaching 0. We just check it. So Claire, if x is negative 100, what's y?
Negative 100.
Over 101, because we have the 1. If x is negative 1,000, Claire,
Negative 1 over 1,001.
so these values are getting closer and closer to 0 as well.
Yeah.
So yep, same horizontal asymptote. You'll hear me say this a lot. I've had lots of students tell me calculus is hard. I've never had a student tell me it doesn't feel amazing when it makes sense.
Yeah.
It does. It just, yeah, it feels awesome. Had a girl come back, I probably told you this as well. She hadn't taken the class for like 2 years. She looks at the board, and she just came back to say hi. She looks at the board and she goes, I gotta be honest, Mr. Smith, I don't miss learning it. It's like, that was a lot of work. But I really miss knowing it. Like, she loved that feeling.
Yeah, it does feel good.
Please.
Could you try, could you do your highest power consumption as well?
Yeah.
Could you do that sometime?
Sure, you want me to write it out?
Yeah.
So if I do that, I'm gonna be finding instead, come over here, the limit as x approaches infinity of my formula. So tell me what you'd write next, Logan.
Negative x over negative x squared.
Because you're comparing the terms, and the negative x in the numerator is the dominant term, negative x squared in the denominator. What would you do after that?
And then you have negative 1, positive 1.
So the x
There we go.
approaches infinity.
So I just, keep track of my factors. Negative 1 over negative 1,
Y also.
x over x,
There's no infinity.
1 over x. This is equal to 1 unless x equals 0. Don't care about that right now. So now I have this.
That number's gonna decline years.
So now you just think of a table again.
That's, so it's almost zero.
So Logan, if x is 100, what's y?
But as this,
1 over 100.
Uh-huh.
that's
Notice they're different, but here we got 1 to 1. And we don't care because we're not looking for the exact value, we're looking for what we get close to. So if this is 1,000, over 1,000.
So you're just saying it's getting closer and closer to 0.
That makes sense. Yeah, same thing.